In this video, I'm going to do a bit of a summary of the things that we looked at in our section on probability and go through a few examples. So the first type of thing that we looked at was finding the probability of getting a certain event from a selection. So a classic example would be given a word and then finding the probability of a certain selection from that. So what's the probability of getting a vowel? So we would look at how many letters we've got. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means our probability is going to be over 10. Then we have a look at what it is we're trying to find out the probability for. So in this case it's a vowel. So I'm going to go along my line and go, okay, I've got a U, that's a vowel. My I is a vowel. My E is a vowel. And I've got an I as a vowel there too. So I've got 1, 2, 3, 4 out of 10. So my probability of getting a vowel is equal to 4 over 10. But we're not going to leave it there because we can simplify this fraction. So we can do that by putting it into our calculator if we're not sure, or we might see that we can simplify that to 2 over 5. In the second example, we're selecting 2 letters from the word cat. Now I'm going to go through 2 ways and 2 types that you'll see. So you might see with a replacement. So that means when you select one letter, you're then putting that back in before you select the second one. So what we can do is we can set up a tree diagram for that, or we can do a table. So I'm going to show you both of those. So if we do the tree diagram, when we choose the first letter, we have the choice of C, A, and T. We put them back in, so when we choose the second letter, we have the same 3 choices. So we've got C-A-T, A-T, ran out of space there, C-A-T. So we could then write our combinations. So we've got C-C, C-A, C-T. We've got A-C, A-A, A-T. And we've got T-C, T-A, T-T. So we've got a total there of 9 combinations. The other way we can do it is set up a table. So we can draw our table and we've got our 2 selections. So we can fill in, we can get the CC, CA, CT, AC, AA, AT, TC, TA, TT. So you can see here how we've got the same combinations that we had written down here in our table. So some people find that a little bit easier to set up than drawing the tree diagram. If you're specifically asked for a tree diagram, obviously you have to draw that, but if you're just given the scenario and you're not told what way to do it, you can choose from those. So you can see in that table we've got the 9 outcomes there. So if we were asked something like what's the probability of getting 2 letters the same, we would look at our table and we go 1, 2, 3. The probability of that would be 3 over 9, which we would then simplify to 1 over 3. The other thing that you sometimes have to consider is that you might be looking at without replacement. So this means you're not putting it back in after you make your selection. So when you draw your tree diagram, you start off with your CAT like you did the first time, but on the second draw, if you choose the C the first time, you're not going to have that as one of the choices. The second time, you only have the AT. If you chose an A the first time, you only have the CT to choose from the second time. And if you chose a T, you've only got the AC to choose from. So when we write our combinations, you'll see that we only have 6 combinations this time instead of the 9 like we had with a replacement. And that's the difference you'll see between with and without replacement. We could also draw that table. But what you'll notice is when you draw that, you can't have a CC, an AA, or a TT, so we put a cross there. And then we have CA, CT, AC, AT, TC, and TA there. So if you were asked the question like we talked about up here of what's the probability of getting 2 letters the same, you can't get that. So that would be 0 out of 6 or 0 as your answer. Another common one that you might see is the scenario if you're rolling 2 dice. So when we do the 2 dice, we generally do a table just because of the size of it. So we're filling in our combinations there, 1, 1, 1, 2, 1, 3, etc. So I've left a little bit here to fill in. So here we've got 5, 5, 5, 6, This row we've got 6, 3, 6, 4, 6, 5, 6, 6. So in that table then we have 36 combinations, and this is why it's easier to do a table than draw a tree diagram with 36 branches on there. So with 2 dice we generally do our table. Then you might look at things like what's the probability of getting a total of 7. So we would go and go, oh, 1 and 6, that'll give us 7. 2 and 5 gives us 7. 3 and 4, 4 and 3, 5 and 2, 6 and 1. So that's 1, 2, 3, 4, 5, 6. So our probability total of 7 is equal to 6 over 36, which is the same as 1 over 6. The other very common one that you might be looking at is flipping a coin. So this one we've got flipping the coin twice. So on the first throw we can have head or tail. On the second throw, head or tail for the first one, and then head and tail for the second one. So we can write our combinations: head head, head tail, tail head, tail tail, and we get 4 combinations there. If we wanted to do it flipping 3 times, we would have our head tail, branch off each of those head tail, and then branch off each of these head tail, head tail. So then when we wrote our combinations, we get H H H, H H T, H T H, H T T, and then we have T H H, T H T, T T H, and T T T. So we have a total of 8 combinations there. And then you can work out probabilities from that as well once you've got all your combinations written down. So you might say, what's the probability of getting at least 1 head? So you would go through and go, okay, well there's 3 there, 2 there, 2 there, 1 there, 2, 2, 1, and we've got 7 out of 8. The opposite of that is getting no heads, which is 1 over 8, and we could subtract that from 1 to get us our 7 on 8 as well if we were going to look at a complementary type event. When we talk about our complementary events, I'm going to talk about that when we look at our notation down here. So the last one that I would want to look at in terms of probability is our Venn diagrams and how to set that up. I do have a more detailed one on Venn diagrams. If you do want to get a little bit more detail on that, there is a video just on putting Venn diagrams together. So we've got a fairly simple version of it. I've got a more complicated version in my video, so if you do want to see that, let me know. But I'm going to go through the pretty standard format one that we will see. So we've got 50 students in total. So I like to write that down the bottom corner. I've got 30 playing a sport, so I'm going to write S, and I'm going to write my 30 up the top there. I have 35 play a musical instrument, so I'm going to write an M for musical instrument and 35 up the top. And then I've got 20 do both, so I'm going to put 20 in that overlap section. That means I can then calculate these 2 parts here. So if I know that the whole circle is 30 and the overlap is 20, then this part must be 10, so that I can get 10 plus 20 gives me 30. Over here, if I've got 35 there and 20 here, I need 15, so that when I do 20 plus 15, I get 35. Now then I want to do a check here and say 10 plus 20 is 30, plus 15 is 45, but I want a total of 50, so I need an extra 5 that are outside. So that's the number of students that don't play a sport or learn a musical instrument. So if we were asking for the probability of someone not playing a musical instrument and not playing a sport, then that would equal our 5 over 50, which is going to be 1 over 10. So you can see this little notation here. So we've got this means and. If we used this one, that means or. So if we wanted the probability that someone played a musical instrument or played a sport, and that would include also doing both, we would look at these numbers here. So when we added them up, we got 45 out of 50, which would be 9 out of 10 when we simplify it. So we're just looking at this section of our Venn diagram, the total that's in there. So we also use the term unison or there, and intersect, so the overlap, and we can use the word and there. We can also put it in a two-way table. So we can use this information up here So we know we've got a total of 50 students. We know that 30 play a sport, so we get a total there. We can have 35 play a musical instrument, so we've got a total of 35 there. And we've got 20 do both, so that goes in this section here with sport and music. This means we can then work out other bits of our table. So I've got the 30 and the 50 here. That means I can work out a 20 there. If I've got the 20 and the 15, I can work out a 15 here. If I've got 20 and 30 there, I can get a 10. 15 and 20 is a 5. And then 10 plus 5 is 15, which I also know 35 plus 15 equals 50 as well. So that then I can read from the table, sport and music is 20. Sport but not music is 10, which is that section of that Venn diagram there. Music but not sport was the 15, and the 5 was neither. So that's how we can put our two-way table together as well. Both of those are representations of the same information, just in a different format. Hope that helps you with your probability and summarises those things that we have done.